All right, so we're going to take a look at the 8.1a notes today. And the first part is kind of a little discovery activity. So I'd like you to go ahead and try 1 and 2 on your own. Pause the video and then jump back when you're done with those. All right, so you just jump back in. So when we look at number 1, most of the time in class, what I see as answers for these is I see people go 2 to 4 to 6, 10 to 15 to 20. And then 12 to 30 usually takes a little bit more time, but people tend to drop right in the middle, which is a 21 in the middle there. All right, and again, it's because they went up by, in this one, up 2, in this one, up 5, and in this last one, up 9, and then up 9 more. So it's nice and evenly split. All right, so this is the average of the two numbers. Or we can think even steps. And when I say even steps, that's with addition. All right, if I look at the next group, we've got 3 something and 27. Most people on this will say 9. In the next one, 5 to something to 125. Most of the time I'll hear a 25 there. In this next one, 4 to something to 16. A lot of times I'll hear 8. Now, this one, rather than adding, we're actually multiplying. So it's times 3, times 3, times 5, times 5, and times 2, times 2. All right, so this one, it's kind of equal steps, or even steps, but it's even steps by multiplication instead of addition. All right, and these two differences really boil down to the big thing that we're talking about first, which is the difference between an arithmetic mean, which we know is just the average of two numbers, and something called a geometric mean. All right, and what a geometric mean is basically like as I move from one number to the next, the middle number is such that if I take the first number times a constant, and then I multiply that middle number times the same constant, I get to the last one. All right, which is really kind of a weird way of thinking about a mean or an average, but it really boils down to two formulas. All right, arithmetic mean, we're just going to add the two numbers together and divide by 2. All right, but with geometric mean, we're going to multiply the two numbers together, the two endpoints, and then we're going to take the square root. All right, so we're going to multiply the 2 and take the square root rather than add the 2 and divide by 2. So these problems can actually be pretty mechanical if we go through them. So this first one says 3 and 12, and it wants us to find the geometric mean. All right, so if I go up to the rule, geometric mean is the square root of the first number times the last number. All right, so 3 times 12 is 36, so we have root 36, which we know is 6. All right, so they're saying the geometric mean of 3 and 12 is 6. And if we check that, 3 times 2 is 6, 6 times 2 is 12, so that matches that definition. So 6 is the geometric mean. All right, if I jump to part C here, which should have been a part B, sorry about that, we've got 2 and 8. So now it's square root of 2 times 8, which is square root of 16 or 4. So 2 to something to 8, middle value they're saying is a 4. All right, because if I go through this, 2 times 2 is 4, 4 times 2 is 8, so 4 is the geometric mean. All right, now, occasionally they'll switch up this question and they'll say, hey, I know the geometric mean, find me the other number. So in this one it says 21 is the geometric mean of 7 and what number? So the what number I'm going to think of as an x. So 21 equals the geometric mean, so square root of two things multiplied together, of 7 and some other number x. All right, so I want to undo that square root, so I'm going to square both sides. All right, and if I grab a calculator here, I've got 21 times 21, or 21 squared, and that's 441, equals 7x, and then I divide 441 by 7, and I get 63. So this would be 63 is the other number. All right, so 21 is the geometric mean of 7 and 63. Because 7 times 63, if I take the square root of that, I get 21. All right, so that takes us through the first page. And where we're going to use this is we're going to use this with this problem. Now, we've seen this one come up several times, and we got really comfortable with, or kind of comfortable, I should say, with drawing out the three similar triangles. We start with the big triangle, JLK. All right, then we'll go to the triangle on the right over here. All right, we know the right angle is at M. All right, and we know it has K, which has to be the same K as the big triangle. So that leaves me with my only choice is this corner up here is our L. All right, then I draw the third one, and I want to orient it the same way. So what I look at is I've got my right angle down here. That's clearly at M. All right, J is shared, if I'm up here on this triangle. All right, J is shared between the big triangle and this one. So J is going to be in this upper corner to keep it easy for me to work with. And that leaves me only one choice, that L is down here in this corner. All right, so we've got those labeled, and those are our three triangles, all right, our three similar triangles. Now, it wants a similarity statement, so I'll go ahead and do that. So triangle JKL is similar to triangle LKM is similar to triangle JLM. All right, and it wants us to write a proportion that contains LM, JM, and MK. All right, so I'm looking for all of these sides. So I've got LM, which is this one, so I'll call that an X. Actually, I'll put that below. JM, which is this one, so I'll call it a Y. And then MK, which is this one, so I'll call that a Z. All right, so, MK. Put that in the wrong spot. So I'll call that a Z. All right, so if I look at this, ML we already have labeled as an X. So I'll go ahead and put a X down there on ML. All right. And we've got these pieces labeled. So what I'm going to do is I'm going to set up a ratio. So I've got X over Y equals Z over X. And if I cross multiply, I get X squared equals ZY. And then I get square root of both sides. So X equals the square root of Z times Y. All right. And this, notice, is the geometric mean formula. If I carry these labels back to the original picture, all right, I have LM is X. All right, I have MK is Z. And I have JM is Y. So notice that the altitude, right, is the geometric mean of the two segments of the hypotenuse. All right, so the altitude is the geometric mean of the two segments on the hypotenuse. All right, and this is going to be one of our shortcuts that we use, and it really is a shortcut. All right, now the next one asks me to set up another ratio. This one is LK, and LK I don't have labeled yet, so I'm going to call that A. All right, so LK, KM, right, and KM we have labeled already Z, and KJ. So I look for KJ there, and I have not labeled KJ yet, so I'm going to call that B. All right, so now we want to take this and set up a proportion for that. All right, so I'm going to circle the pieces in place. So we have the A, the B, and then the z, all right, which is there. All right, so if I look at this, I also have an LK here, so I'll put an A there. All right, so if I set this up, I've got B over A, so the top of each of these, equals A over Z. All right, if I cross multiply, I get A squared equals BZ, and then I take the square root, A equals square root of BZ. All right, now I'm going to carry these labels over, so the new ones we got were the A and B, so LK is A, and KJ, this whole side, we called B. All right, so what this says is it says A, all right, the one leg, LK, is the geometric mean of Z and B, which is the segment under it and the full hypotenuse. All right, so it's a geometric mean, and if I look picture-wise, it would be equivalent to if I drew this picture. If I had A is the geometric mean of B and Z. All right, where Z is that full length of that side. All right. So we've got, and I just want to keep the same labels, so sorry, Z, and then B, which is the full length. All right, now, the next one actually works out to be a very similar rule, and it gives us that if I have the other side of this, which I'll call C, all right, we'd already called this piece Y, and we'll call this still B. All right, we can set up a similar thing and say that C, the leg, is the geometric mean of the segment under the leg Y and the full hypotenuse B. All right, so that takes us through the rules. We'll come back and practice them in the next part of the video.